Well, hello, everybody. Thanks again for joining our live coding session today. My name is Glenn Kunene. I'm the editor-in-chief at Nexmo, the Vonage API platform, and I'll be your moderator. In just a minute, Nexmo developer advocate Aaron Bassett will walk through how to build a text-to-speech messaging app for alerts and broadcasts. So let me give Aaron a proper introduction. Oops, sorry about that, Aaron. So as I said, Aaron is a developer advocate. He previously has been a senior software engineer. He has 15 years of agency and product experience. He's a frequent conference speaker, and he writes a lot of content on our blog at nexmo.com/blog. And so during Aaron's presentation, if you have any questions, please don't hesitate to enter those into the GoToWebinar client, and we'll answer as many of them as we can at the conclusion during the Q&A session. I really encourage you to ask any and every question, and we'll get to as many of them as we can. And with that, I will turn it over to Aaron.
Thanks, Glenn. Yeah, as Glenn said, I'm a developer advocate here at Nexmo, having for the last few months. Beforehand I was a software engineer. So we're just going to go ahead today and go for what it is we're actually going to be building. So our agenda looks a little bit like this. I'm going to go over a little introduction about the actual application that we're going to be building, the kind of text-to-speech voice broadcast. We'll do some live coding, so you can actually see we develop the application. It's going to be in Python, using some kind of async and things. Don't worry if you're not a Python developer. Most of the code is pretty straightforward. If you've got experience in another language, you should be able to follow along. While I'll be doing it using kind of our Python client, we do have clients for most of the major languages, so PHP, JavaScript, Java, .NET. We also have SDKs for iOS and Android. So just because I'm writing it in Python, because that's what's most familiar for me, don't feel that we only support Python. And then afterwards, hopefully that all goes okay, and then we'll have some questions. So as Glenn said, if you can just pop your questions into the chat in the GoToWebinar software, then he'll ask them to me at the end, and we'll try and get through as many as we can. If there's any questions that I don't get to, or any where I may not know the answer, if it's about one of our other client libraries, etc., we do have a Nexmo community Slack, and you can sign up for that at our developer portal at developer.nexmo.com. Okay, so let's get started then. So what are we going to build? Essentially, we're looking at a voice broadcast, so a notification system. And normally when people think of notifications, they might think of SMS. That's kind of become the de facto way of sending notifications to people. In fact, it used to be whenever I receive an SMS, I would know it's going to be from a friend or family, etc. But now my friends all use Facebook Messenger, or my more security conscious friends might use WhatsApp, or my paranoid friends might use Whisper. But even my mum actually now sends me pictures of my niece via WhatsApp instead of email. It's like everybody's kind of moved away from SMS and into these different channels now. So most of the time, whenever I receive an SMS, I know it's going to be a notification. You know, the only time I get them is from like my bank, or from whenever I request a 2FA code, etc. So it's kind of lost a little bit of that impact, which is fine. You know, not every notification needs to be read immediately, but sometimes you have these critical alerts. And those critical alerts need to be dealt with straight away. And that's what we're looking at today, is using text-to-speech for doing voice calls, because it's a lot harder to ignore a ringing phone than it is to miss a text message. So let's just start sketching out what it is we're actually going to be doing today, just to kind of get it clear in our heads what it is we're building. I always find it kind of makes sense just to do a little diagram first. So first of all, we're going to have some kind of trigger. Now, what I mean by a trigger is this could be really anything. You know, so some of the kind of examples we thought of earlier was like, you know, maybe you're getting a package delivered, So you want to inform your users that the package is about to arrive, or maybe it's a lot of users in a particular area and there's been some delay at a sorting facility. You want to let them all know. So you're gonna have like quite time critical notifications there. Or maybe it's you're doing a weather service, and you have like some kind of warning about, maybe there's snow on the way and you need to cancel school for the day, need to inform all the parents, or maybe there's some other kind of extreme weather condition. Or you're a developer and you have a series of servers all sitting in a rack somewhere, and the servers all catch fire. You're going to want to know about that pretty urgently to go in and get those fixed. And all these kind of things that we have over here, these are all our triggers. These are all things that are going to creating events that we're going to want to know about like pretty urgently. So we've got our triggers over here, and these triggers then they're going to be feeding into our actual application. So what we're going to be building today is this part here in purple I'm just drawing now. So this is our app. And this app is going to be responsible for receiving notifications from these different triggers, and then forwarding them onto Nexmo. And Nexmo is going to take care of doing the transformation from text into speech and the phone calls and all that kind of stuff. Now our app as well, we may have different people responsible for different types of alerts, or in the case of like the weather one, we may only want to send these critical alerts to people in a particular area. So we're going to need some kind of database, and that database is probably then, let's say it's our contacts, and our app will have some way of like querying the database and finding out which people need to be notified. So once we have a list of people to be notified, then it all gets handed off to Nexmo. So over this side, then we'll have Nexmo. And our Nexmo, as I said, we're going to be using the Nexmo Python client a little bit in this, but it actually is just a REST API with JSON Web Tokens. So no matter what language you're writing this in, if it can make a HTTP request, you can use the Nexmo API. So essentially, once we've got this list from our contacts, we're going to be sending a request to the Nexmo API, telling it to initiate a phone call. In fact, we're going to be sending a lot of requests. We may have lots and lots and lots of users going across, so we're going to need to issue a request for each one. And once Nexmo has or receives this request, it's going to initiate like a telephone call to the user. So we have our user here, and Nexmo is going to make a telephone call, and it's going to take wait for the user to answer the phone. So whenever they kind of answer, the Nexmo is actually going to call back to our service. And the reason for this is like we're telling it here to initiate the actual call, but once the call has been created, Nexmo needs to know what to do now. What should be what action should we perform. So ask our server again, and then our server replies with what we call an NCCO, and that's a Nexmo call control object. Essentially, it's a JSON file which contains an array of objects, and each object is an action that we want to perform. And in this case, the action that we're going to perform is text-to-speech, TTS. So we're going to take whatever the notifications is we get from our triggers. We're going to figure out which contacts it is that it applies to. Then we'll get Nexmo to call those contacts, and then once it comes back to us, asking about the about what to say to the contact, our NCCO then will have the text that will be replied to them. And one of the other cool things as well is our event system. So say, for example, we need to be sure that it's a server outage, and we need to be 100% sure that that call went through and that the engineer is handling it. Well, with Nexmo, we'll get different events depending upon what's just happened in the call. So the first event we'll get is like call started, then we'll get ringing, then we'll get answered. Hopefully we'll get answered. There's a couple of ones we could get instead of that, but we'll get answered and then we'll get complete. So all these different events will be coming back from Nexmo into our app again, and we can record those. Now, maybe something happens where we don't actually get through to the user at all. Maybe we hit an answer machine, or the call fails for whatever reason. We'll also get that notification as well. So we can record that against the user for that event, so we know that they didn't receive the notification, or that we didn't actually get to speak to the user, that we had to leave a message for them. All those kind of things are possible. So let's start looking at some of the actual kind of code then, once it's connected. So we have our triggers going to an app, which is going to go to the next one, which is going to initiate our telephone call. So the first thing we're going to look at really actually is this NCCO. It's pretty straightforward. It's going to get it out of the way first, because the rest of the stuff we're going to be talking about kind of relies upon that. So I'll put my tablet away. Okay, so I've already kind of created a folder. There's nothing in it as of yet. I'm just going to open a terminal so we can have a wee look at it. So if we have a look in our broadcast folder, we can see it's currently empty. So first thing I have to do is just create a new kind of Python environment, get some of the different requirements that I need installed. So we want to be using probably 3.6.2, and we're going to create our new virtual environment, and let's just call it broadcast as well. Okay, so that's gone off and it's created our new virtual environment. We should be in that right now. So if I do my Python version here, yeah, I've got my 3.6.2, so that's great. So I can actually start installing my different requirements. So for the server part of it, so the server is going to be providing our NCCO, our Nexmo call control object. It's a JSON file. It's also going to be responsible for receiving our events. So that'll be things like calls ringing, calls answered, or call didn't complete. So for that, we're going to be using a Python package called Sanic. So we're going to need to pip install Sanic. We're also going to need the Nexmo Python client as well. And for that contacts database, we're going to be using Mongo. So I'm just going to install PyMongo while I'm at it. So while that's installing, let's have a look at the Mongo database that we just briefly mentioned there. So I can just log in. Now I've actually created this already as contacts database, and I have a contacts collection, and I have a few telephone numbers in that already. And I only have kind of 8 in there right now. Obviously, for an actual production system, you may have hundreds or thousands of different numbers in there. But for our demo, we're just going to stick with those kind of 8, and still should be enough for us to kind of see running through it. If you've not used Mongo before, or any kind of document store, don't worry. It's just a place for us to keep kind of our number information. The actual documents themselves are really straightforward. They just have a single key value, which is number. So we have let's get rid of that. So we have everything installed now. If we do our pip freeze, we should see our requirements. Yeah, cool. So we can see there we have kind of Sanic installed. It's also installed things like kind of our I/O files that it needs, and WebSockets, and UV loop, and all that's lovely stuff. So let's create a new file then for our server. So we're going to just call it server for ease. And let's go into our edit mode. So with our server, as I said, we're going to need to serve up 2 things. We're going to have our NCCO object, which is just a piece of JSON, which is going to be via GET, and then we will have our events endpoint, which will be a POST request, and that's going to store the information about our call. So we can tell if it's been answered or if it's went through an answer machine, etc. So first of all, we're going to need Sanic. So let's just import that. Let's go to capital S, my autocomplete, thinks it knows better. And then we're going to have 2 different kinds of responses. So we're going to need to have the JSON response for our NCCO, and then just a regular text response whenever we get our event. We're not actually going to store the event data anywhere at this point, so we're just going to import log0, just so we can actually see the output of that as an example. But we'll need to pip install that as well, actually. So let's pip install log0. Great. So log0 will just give us some nice colored output in the console, so we can kind of see what's happening whenever these events come in. We'll need to create a new Sanic app. And then once we have a new Sanic app, we can actually start creating our routes. So let's just create our first route, which is just going to be, our index, and we're going to make that async, and let's call it answer, because that's going to be our answer URL, and that's going to take a request, and it's just going to return our JSON. So in this instance, we're not going to be doing anything kind of fancy here. We're just going to be using our text-to-speech. So this is going to take a Python object and convert it into our JSON response. Now with our Nexmo call control objects, they're all arrays. They're a list of actions. So we're going to create a new array, but we're going to have the one action in this, which is our text-to-speech. So let's just fill that in now. So first we're going to specify what kind of action it is. And in this case, it's going to be a text for our text-to-speech. And then we need to tell it, or sorry, not text, talk even. And then we need to tell it what it is that we want it to say. So that's where our text comes in. So let's just use the example of maybe our package stuff. So and then we can have that sent out to everybody, so they're going to know that we've got some new toy that's arrived via our UPS or DHL or whoever your postal provider is in your country. And then we're going to create a second route, which is just going to be for our events. We're just going to call that actually events. And this is slightly different in that it takes a post request instead of a get request. So we need to specify that there, otherwise Sanic will reject it. It assumes it's going to be a get request, and you need to specify otherwise. Again, let's make this async, so it's not blocking, and we'll just call it event. Again, it's going to take a request. And in this instance, we're just going to probably just actually return the text. We'll fill in the rest of it a little bit. So we're just going to return our text response, and we'll just put in here, to do for now. So that's not really going to do anything just yet. We'll come back to that later on. So the final thing we're going to have to do then is make sure that this actually runs. So we're just going to do our name equals main. So this allows us to run it just from the command line. And we're going to do our app.run. We're going to just run this on our local host for now. So that'll be so it should like connections from wherever, and we'll specify a port of 8000. So essentially, whenever I do Python space server.py now, this is going to execute, and it's going to run my Sanic app, available to anybody essentially. It won't be available publicly just yet, and on port 8000. And then we have two routes. We have our index, which is going to respond with this, our JSON file, and then we have our events, which only accepts post requests, and it's just going to return this text to the moment. So we can actually let's give this a try. So if I do Python server, maybe if I saved it, it would be better. Let's just disable my number for the time being. Oh, amnesia. Sorry. Of course, that needs to be. Where's it not going to match? Disable number for now. And there we go. So Sanic is running. on our local host on port 8000. Let's just start up our browser and we can go have a look at that. Okay, so we can see here that we've got this, I see a piece of JSON that's coming back, and we have this action talk and our text of, I got a new package. So we can see that one's working. If we try to go to our events, we should get this, get is not allowed for that URL. And that's because we specified that it should only accept post requests, because our event notifications from Nexmo are always going to come in as post. Okay, so that's our server setup. So whenever we do this kind of callback from Nexmo to ask what it is that we should do, it'll now serve up the NCCO file correctly. Because we need to make it available publicly, we're going to need another terminal, and what we're actually going to use is a tool called ngrok. What ngrok will do is it'll create an SSH tunnel and make my local server that's running on this on my local host available publicly. And the reason for that is whenever Nexmo tries to contact my server in order to request the NCCO file, it needs to be available in the public internet. So I already have a app set up for this. I think it's Nexmo broadcast apps. There we go. Okay, so what this has essentially done is it's created a tunnel from this URL to my local host on port 8000. So if I go to this address now, we can see I'm getting that same JSON file, that same NCCO is coming back. We have a post on our blog which goes into kind of ngrok with a lot more detail. So go read the blog post if you think it's something that might be useful for you. If you're doing any kind of development work locally, it's really, really handy. It gives you kind of nice information about your request. You can see there that I got a 200 for that get, but my browser also tried to request a favicon, which I obviously don't have, so it's got a 404. What I can also do is I can use the debug mode or this web interface to debug my requests. So this is also part of ngrok, and we can see here is my 200. I can see that all the headers that my browser sent, but more importantly, I can see what I've replied with, and we can see in this headers that it's got this content type of application JSON, which is what Nexmo is going to expect it to have as well, and also this 200 HTTP code. So that's perfect. That's exactly what we required. So the next thing we're going to want to do then is, well, let's look at actually sending our first voice call. Now, normally whenever you're going to be doing a voice call, let's just create a new file for this. So we'll just do a single voice at the moment, rather than doing kind of our mass broadcast. And normally if you're doing kind of voice calls with Nexmo, you're going to import the Nexmo client, where all our numbers are stored in Mongo, so we're going to use this by Mongo as well. And we're going to need to import the Mongo client. And all my application keys and things like that are actually stored in environmental variables, so I'm also going to import OS so I can access those. So again, let's just create our names. We just run this. I will remember to put double unders this time. And then we're going to create our database client, which is going to connect to our Mongo database. I'm just going to grab this so to get the connection string right. It's going to connect to our Mongo database, and then we are going to get our collection, which is equal to our DB client, then our database name, which was contacts database, and then our collection name, which was contacts collection. So this is giving us a reference to this collection of documents within our MongoDB. We need to set up our Nexmo client as well. Because I have everything stored in environmental variables, I can just use them in here. So I'm going to go like Nexmo.client, and we're going to need to know our application ID, which is os.environ. Let's it's going to be broadcast application ID. So if you don't know what an application ID is, in Nexmo, whenever you're looking to make kind of voice calls and things, you need to have a virtual number. So we have a Nexmo CLI, which you can use. I've got it installed in my system, already configured. If you look on our developer portal, you would define things like this. So actually, it's under SDK and tools. You can see our Nexmo CLI. So this is our command line interface in. It's got a bunch of stuff. It's really easy to set up. Just takes your API key and API secret. And once you've got that set up, you can do an awful lot of things. So for example, I'm going to need a number in order to make any of these telephone calls. So I can just do Nexmo number search. It needs to be able to support voice. Oh, I see. I'll need to know which territory. So it's going to be, I'm in the UK, so I'm going to use GB. It's going to need voice, and let's just limit my results to 3, for example. So that's going to return some numbers that are available, some virtual numbers on Nexmo that are available to purchase. So if I wanted to purchase one of these, I could just go like Nexmo number buy, and then specify which number it is. So let's take this top one here, for example. Okay, and it's going to tell me this will charge my account. So I know in the UK, I think it's like 50 euro cents a month. So I'm okay with that. So I'm just going to confirm it. And I've now purchased that number. So that'll be available for me to use on my Nexmo account. I can assign it to different applications and make calls from it, or etc. So now I've got a number like purchased. I'm going to need to create a new application as well. So I'm going to go like Nexmo app create. I'm going to give it a name. So let's just call it broadcast demo. It's going to need to know what my answer URL is. So that's the URL that the NCCO is provided on. So that's going to be this one. So I'm going to put that in as well. And it's also going to need to know where to send those events from those webhooks. So that's going to be the same URL, but events, I think is what we call that route. So we have a look at our server again. Yeah, we just call it events. So that's going to be on our events. And then we can actually have it generate a key file for us as well. I'm just going to put this into temp key at the next. I'm not actually going to use this key file. What a key file is all the authentication whenever doing our voice calls is actually done using JSON Web Tokens, which we need to have this kind of private public key. So whenever we use the key file, it's going to generate our public key, attach it to that application, and then save our private key for it. So there we go. So we can see that an application was created. I've got the unique identifier for that application, and it saved my private key to temp key. So what I can now do is, now I've got the application, I can actually link my app to my number. So I purchased this new number. I can pop this in. And then I can add in my application ID. And those will be linked now. So whenever anybody calls this number, it will attempt to get an answer NCCO from this address, and it will post any events to this address. Now I've already actually got an app set up, and that's my application ID that's stored in our environmental variable and things. So I'm not actually going to use this temp key, so I'm just going to get rid of that before I mess it up. And I'm just going to copy across my existing key. Okay, so I have my key, which we're going to need to later on to do any of our voice calls, and we have kind of our server here and our single voice, etc. So I have my application ID that we just discussed, and the next thing that I'm going to have to put in here then is my private key, which I just copied across. So it's going to be private key, and I think it was called broadcast key. And then finally, we're going to have to get, well, we're just going to do it for one contact at the moment. So we're just going to do like contact equals collection dot find one. So that's just going to grab a single document from this document collection, and then we're going to make our actual call. So we're just going to go response. We're going to use our Nexmo client, and we're going to pass into, or sorry, Nexmo client, and we're going to go create call. And create call is a method. It takes a dictionary, a Python dictionary, and it's got a few different attributes in there. So let's just try, I'm just going to put this across. So we have kind of, you know, our type of phone. So this is our two, so this is who we're going to be calling. We have our numbers coming from this contact here, from this find one, and then we have our from number. Now our from number needs to be a Nexmo virtual number, like the one that I just purchased, you know, up here somewhere. I have the one for this stored in an environmental variable as well. And then we can supply our answer URL. So I know we can supply our answer URL here whenever we're setting it up, whenever we're linking it, but we can also specify a different one here if you wish. So that's it kind of all set up. So I'm just gonna like print our response from that. And then we can have a look. So if we go back onto our system, let's work on broadcast to get our virtual environment running again. So we should be back in our, whoops, not Python verbose, so it is Python version. Yep, so we're back in Python 3.6.2. And let's try running our single voice if I've saved it. Okay, so we can see this is the response that came back. I have a unique identifier for that, and you can hear the call coming through on my phone.
Yay, I got a new packet.
Hopefully you'll be able to hear that kind of text-to-speech there. So that's created a call. We can get a UID for that call. We can see the status here as I've started. If we look at our kind of Sanic log that's coming out here, we can see the GET request that happened, and then we can see all the different post requests for our events, and then we can also look at those in our web interface for ngrok. So let's go back here, and we can see the different events. You know, so it's posted that it started, that it's ringing, that it was answered, and then we probably should have yeah, and then completed. So we can see all those different kind of events that are coming through and how they can be really useful for tracking who has managed to get or who was notified and who wasn't. Now the only issue with doing it that way is, well, let's just run it again. So we've got Python single voice. This time we're just using this time parameter at the start so I can see how long it actually takes to execute. And it's pretty quick. My phone's going to ring again in a second. You know, it's slightly over a second. Not so bad, you know, which is fine if we're only sending a couple of notifications. But once we start to get into the realms of like hundreds or even thousands of notifications, that's a long time for that to be sitting waiting on those requests to go out. The reason for the delay is you're obviously making a request across the internet. You know, you're making a request out to the Nexmo servers. There's going to be latency involved there. So how can we improve this? How can we make this so we can do large volumes, like a voice broadcast rather than a single notification? Well, that's where kind of the async stuff comes in. So let's create a new file. We'll just call it broadcast.py. And then we can start looking at doing some of the async kind of sending. So for the async stuff, it's a little bit more complex. First of all, we're going to need to create an event loop. So we're going to just define this run event loop, and that's just going to be our async event loop. Now, for anybody who's not done any kind of async stuff before, essentially anything that's running within this loop, we can basically say that we want to kind of release the thread back again, so that rather than everything having to execute, you know, one after in sequence, we can go, okay, while we're waiting for this part to execute, you can start the next iteration of the loop. So we're going to create our new loop, and we're going to need our async IO. So we'll probably do our imports as well as we're doing this. So we'll import our async IO. So I get my completion stuff. yeah, so we're async IO, and that's going to we need to get an event loop. And once we have our loop, we're going to create our future. And then we're going to ensure that, in order for this to complete, we're going to ensure that our future, which is going to be this broadcast method that we've not written yet, we'll have our future and reference to our future and our loop. And we're going to run that loop until our future completes. So run until complete. And we'll tell it we want to run it until everything's completed in that future, and then we're just gonna debug our future.result so we can see it in the terminal once it's complete, and then we can just close our loop. Okay, so let's again just run that. Whenever we do our Python broadcast.py, let's just run, and we're just going to run that event loop. Now, at the moment, that's just going to give me a syntax error because we've not actually defined our broadcast method, and we've not imported our logger. So let's, I think it's log 0, isn't it? Yeah. So let's first of all going to define this broadcast function. So the broadcast function, it's going to be responsible for lifting all the contacts out of our database and looping over them and then passing the information off to another method, which is going to actually create the call. So we want this to be an async method. So we're going to just use async keyword. Now, all this kind of async stuff, I think it only came in Python 3.5. So you are going to have to be using a fairly recent version of Python for this kind of syntax to work. I think you can use it with yield and things before then, but we're just going to focus on kind of the async stuff. So we have, again, I'm just going to bring this across and watch me type out all the database strings. So essentially, this time we're connecting to our MongoDB again. We're getting a reference to our contacts collection, and then this cursor is just pointing to the entire contents of that MongoDB. Now, you might notice that this is not the same way that we connected before. We don't want our MongoDB connection to be blocking. There's certain things that you can't do within some of these async event loops because they're actually like blocking actions themselves. The regular just PyMongo is one such instance, so we're going to use motor instead. So let's make sure that's installed. So we're going to pip install motor. Okay, so there we go. So it's installs. Actually uses PyMongo under the hood, but we've already got that installed, so that's fine. And then we can actually go ahead and import that as well. So let's just import motor dot motor. I think it's actually underscore. There we go. Okay, so that's our motor async IO imported, ready to go. So we can get our database connection. And then once we have our database connection, we're going to need to loop over that and actually create our HTTP requests. Now, I have a bit of a confession to make on this one. Our Python library does not currently support kind of async. It uses a library called requests under the hood for doing any of the HTTP requests, so any of our gets and posts, etc. And requests is blocking. So we're not actually going to use the Nexmo client library here. We're just going to just use HTTP, we're just going to create our own kind of request directly against the REST API. Hopefully it'll actually demonstrate just how straightforward it is to use our API even without the client wrappers. They are a very thin wrapper around stuff. But just so you know, that's why I'm actually making the request myself rather than using the library you saw me, or using our client library from earlier. So we've got this async IO HTTP library, which we probably should install as well. So let's install that. that's correct. There we go. And let's import it as well. So it's going to create our session. It needs to have a reference to the loop that we're executing it in. And let's go. So we're going to create that session as session. And then we need to gather our list of tasks. So we're just going to use a list comprehension here. We'll have a new method called createCall. That method, well, it's going to need our HTTP session so it can actually execute things. And it's going to need to have a reference of the number they want to call. So that's going to be in our, we'll call it document number. So we've got our create call, and then so it's going to be for document in, and we can use our wait keyword here, so we are non-blocking to list. So essentially we're just converting this contacts collection to a list that we can iterate over. We also need to provide it with a length. So we'll say the maximum we can do here is 100. I know we would have 8 in there. You can obviously make this much bigger. And then once we have our list comprehensions, list tasks is now a list of all these create calls, one for each number that's in our contacts database. And then we're just going to go, await, and we need to gather these. So we got erase. Oh no. IO, and it'll be gather actually for these, and we'll just explode that out. Great, so this will run through, create our calls using our create call methods. We're going to wait until all of those complete, and then once that's done, we're going to tell our future that we're passing in here into our broadcast. We can go future set result, and let's just say what attempted to ring, and we just use what's the tasks, the length of the tasks, and that should. So once this is complete, we're going to get this. The result of our feature is going to be that attempted to ring n numbers, where the n is like the length of this task list that we're creating. In fact, that should be fine. So finally, then we need to create our call, because again, this method's not defined yet. So this is where we're going to be doing the actual kind of heavy lifting of creating our API request in Nexmo. So again, let's make this asynchronous. We call it create call. It needs to have a reference to the HTTP session as well as the number it's going to call. And once we have that, so let's just put a wee log in here to say, what we're going to say, just that we are starting call to number. And then within here, we're going to have to create like our Nexmo client or our request to Nexmo. Now, this is where we normally would use the Nexmo Python client, as explained earlier, because it uses requests under the hood. We won't be able to do that, so we're going to have to create our own, essentially. So just to keep things nice and tidy, I'm going to create a new class. We're going to call it broadcast client, with a capital L. And it's going to need a few things. So we're going to need to know what our application ID is. And that's installed in our environment, so let's import that first. So we've got environment, and it's broadcast application ID. There's a few more. Rather than you say, it's not very interesting me typing out budget constants, so I'm just going to put these in here for us. So essentially what we have here is all the information that we're going to require in order to create our JSON web token, as well as things like, where's the number from. The user agent, we're going to use in our request. We can specify that. So whenever we're looking at logs and stuff, we can see which one of our applications is created, and we've got our answer URL in there as well. So once we have that done, now what you may think is, well, we want to create this and it needs to be asynchronous as well. So maybe we do our async define init, but no. Python really does not like it if you try to do kind of asynchronous stuff with some of the magic methods. So instead, we're actually going to use a kind of factory pattern. So we're going to create our own method called create, which is going to be a class method, and it's going to take our number 2. So we need to actually specify that's a class method here. So the CLS that's going to receive is obviously a reference to the class itself. And then in here, we're just going to redefine self to an instance of our broadcast client. And then we can start setting attributes on that. So we can do like self, and then we can specify this number 2 equals the number 2 that's been passed in. What else we need to do? Well, the other thing we need as well is this private key file that we have here. That's actually just the file name. We need the contents of that file. So we're going to have to read that in. Now, obviously, reading the contents of a file, again, is a blocking action. We want to do that with async too. So we're going to need that async IO, import async IO files. I think we already have that installed, but let's just check with our pip freeze, and we'll just grep for async IO stuff and see what we've got. Yep, AIO files, that's great. So we've already got that installed, that's fine. And we can use that in here then to read the contents of our private key. So we're going to go like async IO with AIO files, and we're going to open up this private key file. So what mode do we need? We need mode R. And we'll just specify that as key file. And then we'll set our private key to the contents of that key file then. So we can see key file. Read. But we'll actually need our weight in here as well, just to make sure it's asynchronous. And then we can just return our reference to self. So essentially here we're basically just creating an instance of this broadcast client, and then we're setting some of the attributes on it and reading in the contents of our key file. And that'll all get returned. So it means in here, whenever we're creating our call, and we want to create our client like we did before with our Nexmo client, it's really quite simple. We just do client equals await, and then we do our broadcast client dot create. Notice that I'm not creating an instance of this first, because that's a class-based method, our class method. I don't need to do so. I'm just going to call our create, which is going to return an instance of it anyway. And our create also requires reference to our number that we want to call. Now, whenever we are making any requests to Nexmo, we also need to provide a bunch of headers. So this is how we actually authenticate with Nexmo. So we're going to do this like get headers. And it's going to be just a regular class method. First thing we're going to need is the current timestamp. So we're going to do time.time. These are all kind of, if you've worked with JSON Web Tokens before, this will seem really familiar. This is not something unique that we're doing here. It's just import time. So we have reference to it. We'll create our payload next, which is going to be a dictionary. So first key is going to be that time that we just created a second ago. We're going to need to know our application ID. which we actually have stored on this now as application ID. We're going to need to know how long the token should last, so we're going to give an expiry of the current timestamp plus 60, and then request our API, which is going to be just a unique identifier. So we're going to use just built-in UID for this. So we'll do UID.UID 4. So that's just using Python's built-in UID, which we'll need to import as well. And then once you've got all that, we can actually create our token. So we'll do jwt.encode, and we'll pass in our payload, our private key, and what algorithm do we want to create it with. And we're going to use RS256 for this. So algorithm, if I can spell it correctly, 6. Spell, yeah. Okay, so that's our token created. So now we can add this to our headers. So we're going to go to headers, which again is just our dictionary. This is where we specify that user agent that we created earlier. So I'm just going to say user agent is going to be equal to the user agent on our objects. And then authorization will pass through our token here as well. So authorization. So another one that's always good to spell. Error, and we need to add on our token. We'll decode it as UTF-8, because otherwise it's going to be in bytes, and it's not going to allow us to concatenate the string with bytes. So we'll do our decode first. Okay, so now we've got all our headers, and we can just return that. And then in our client request here, we can specify like our headers equals client dot get headers. So that's going to be just this dictionary now, which is going to have like our user agent, but also the most important bit is our JSON Web Token. So we're actually using this JWT library, which we'll need to install as well. I think it's, let me just look up, yeah. So we'll need to do a pip install on that. Already installed. I think, oh yeah, because we've installed Nexmo and it uses it. But we'll need to import it into our broadcast file here as well. So it'll be for JWT. And then finally, we'll need to actually get our payload. So this is what we're going to be sending to the endpoint, which is just going to be, we could just put it, write it ourselves in the extra thing, but why don't we keep all tidy and put it in here. It's going to be a dictionary, which is going to contain some information. It's the same thing as we saw before, being passed into the Nexmo client, exactly the same, just this stuff. And over here now, the number 2 and the number from is just coming, and the answer URL is all part of this broadcast client. Keep it nice and neat. So we can specify here then our payloads is going to be client.get payloads. Payloads. And then we're kind of ready to make our actual call. So again, this is going to be async. We're going to do with our session, which is a reference to this client session here, and it needs to be a post request for any of these kind of stuff, and it's going to hit our Nexmo endpoint, which is our api.nexmo.com v1 calls, because it's our voice call we'll be creating, and then we can pass in our headers. Our payload is actually going to be sent as JSON, so we'll do JSON equals payload, and then we'll just as response. Okay, so that's going to make our request, and then we should get back our response, which is going to contain things like our status. So we can just be like status equals response status. But also we'll probably want to get the body of it, so we'll just call it Nexmo response. and let me sync response.text. And then finally we can just log the info about it. So let's just go like logger.info, and we'll say, what do I want to say about this? What that we call requested for, or call requested to number, and I'll probably want to put in here just what the status of that was as well, so we can see that in our logs. Okay, so that is going to, whenever we run our loop here, it's going to run this broadcast, which is going to connect to our MongoDB. It's going to get all of our contacts. It's going to loop through each contact, and it's going to issue this create call. And our create call then we've got up here. It's going to create a new client, which is going to generate our, well, sorry, it's going to, first of all, it's going to read in our private key. Then it's going to generate our JSON Web Token. And then it's going to use those to initiate a API call to the Nexmo voice API with kind of our headers and our JSON payload. And it's going to wait for a response to come back, and then it's going to log it. I don't want to run this as it is at the moment. The reason for that is because I'm doing it all async, that this can be very, very fast. This can make a lot of requests per second. And the Nexmo API does have rate limiting. So our rate limiting at the moment is actually two post requests per second. So I'm just going to bring the, I made a couple of amendments to this, which I'm just going to bring across now as well. And the amendments is I've created this Nexmo rate error exception. Now whenever you get a rate error from Nexmo, you can see in our create call here, I've now put in this conditional. So it's saying that if the status is 429, which is the status code we'll get back if we're being rate limited, then we're going to raise this Nexmo rate error. And the reason for that is I've also imported this package called backoff, and it's going to look on exception. If the exception is a Nexmo rate error, then it's going to back off. And what that means is that it's not going to immediately retry. It's going to wait a little while, and then it's going to retry again. And this expo is for exponential backoff. You know, so the first time it might wait a second or half a second. Next time it might be 2, then 5, 20, a minute, etc., etc. And I think it'll go right the way up until it's waiting 24 hours. We shouldn't have to ever wait that long, but that's what the backoff kind of exponential, well, what its max kind of set is at. So the other thing we have in here is this backoff exception handler, and that's just a really simple method we've got up here, which is going to tell us that we're being rate limited and that we're backing off for X number of seconds and that we've tried Y number of times. The second one backoff we've got here is this on predicate, and what that means is this is going to wait for a true or falsy value being returned from our function. So if it receives a falsy value, it's going to assume that something's gone wrong, and that's when it's going to kick in this back off and then rerun the function in a little while. So whenever we get this response text back from Nexmo, if it successfully initiated the call, then it'll have started as the status. So you can see here at the bottom now, I'm returning the result of this conditional, like started in Nexmo response. So if that string does not appear within our response, this is going to be falsy, and our backoff condition is going to be met, and it's going to back off. And this actually uses a slightly different when it's used the Fibonacci. You could just make it use exponential as well. It doesn't really matter. But what I've specified here is a max tries of 5, and the reason for that is if this is not starting, that's a lot different than it being rate limited. You know, there's something wrong. It might be that the number is invalid, or that we don't have credit, or a bunch of other different things. So we probably don't want to just keep hammering it until it goes through. It's not like we just need to wait a little while like a rate error would be. So that's why it's got max tries of 5. You know, if it's still not going through after 5 tries, we'll just stop. And again, we have a handler for that, which is going to tell us, call it and stop backing off for whatever. So let's just install. We have a few more requirements that's going to be introduced Rather than listing them all out, I'm just going to take them from what I prepared earlier. Make sure everything's installed that we need. Great. So we have our back off is installed, etc. And now we can actually try running this. So we need to have our server running, which we do. We've got our Sanic server here. We have our ngrok server running, and now we can try running a broadcast. I'm just going to make one final change actually to the Sanic server before we do that. So let's just kill this for a second. And remember we had our event endpoint, which wasn't really doing anything. It just has this, to do. Well, let's just pop some stuff in for that. So what I've done here is this event is going to receive some JSON in the request body. So we're just doing request.json to get access to that, and it's going to have a status. So that status is going to be, it's started, or it's ringing, or it's answered, or it's complete, or etc. etc. So what I have really is if it's if it's started or it's ringing, we're going to log it as a debug message. If it's answered or complete, it's going to just be info. But then if we have something like hit an answering machine, or it just rang out, or the line was busy, it's not an error, but we probably need to flag that up because we'll need to try again later. So it's going to just log that as a warning. If the call failed or timed out or was rejected, that's going to be an error. So we're going to set our logger to error, and then anything else, which it shouldn't be anything else, but just in case, we're going to log as debug. And you can see here it's doing log, whatever the status was, and we're going to go like new broadcast event with status, whatever it is. And this is going to return some text. We'll never see this because it's actually Nexmo. They'll be calling that endpoint, so this we'll never really see, to be honest. Let's start our server. I'll make sure I've saved it. Save that up, and start our server again. Okay, so Sanic's running. ngrok's still running, and now we can try doing our broadcast. So let's just do Python broadcast.py, and should start giving us some output. If I've not saved it again, I really need to just have it like automatic save. So here we go. So we can see it's calling a bunch of numbers. I'm getting rate limited because they're going through really, really fast. So we can see that it's things like rate limiting, backing off for 7 seconds, backing off for 4.8. Then it's going to retry. We've got our status codes here, so what we're looking for is this 201. As we find out that all my phones in my house are not set to silent, but we'll try just entering one of these. Okay, so we should see more events coming up here completed because I answered that call. I'm just going to reject that one. Yeah, I've got. When you work in telecommunications, you tend to accumulate phones for testing. So I just had about 4 or 5 start ringing or vibrating on my desk. So yeah, so we can see here it attempted to ring 8 people, which if we remember from our Mongo, let's use our contacts database again, and then we'll just do like DB contacts collection. Let's count 8. So it's tried to attempt to ring each of those, and we can see here, if we just go scroll back through our logs, we've got our initial kind of ones. So the first one is like, this 925. You can see, like maybe whatever that. So this is our first one to complete, which is 789, which doesn't actually occur until right way down the bottom, but that's the first one to complete. So you can see how the async works. They're not all just firing off in the order in which we've requested them. It's just, it'll fire a request and then move on to the next one and wait until it gets, and then like free up that queue until it gets a response. And then we can see we start to hit a rate limit pretty quickly because we fired these 8 like in a row. And you can see here the kind of exponential back off. Now the reason it's not completely linear or doesn't have a real pattern to it is because we use a thing called jitter. There's information on the backoff GitHub repo about why we use a jitter and why it's recommended by people like Amazon. So if you're interested in kind of exponential backoff and jitter, it's a good read. I recommend it. But you can see here the backoff times are getting larger and larger. The final one coming out about 8 seconds. But eventually, all our requests went through, and you heard my phone ringing and other ones vibrating off my desk. But yeah, that's really kind of it, to be honest. So kind of the takeaways from it is whenever you're doing it for 1 or 2 people, using just a standard client library is probably fine. If you start to get it for large numbers of people, you're probably going to want to run it using kind of async, probably using some kind of message bus as well. I'm just lifting like the entire contents of that database out. You'll probably not want to do that. You'll probably want to shard it or just lift out parts at a time, as I said, using a message queue or message bus for it. But that's really kind of the basics of voice broadcast. So I think I'm going to hand back over to Glenn. I'm just going to put a couple of links up here as well, just so we do the questions. So these are just our developer portal, our Nexmo community where this code will be available later on today, and then the Nexmo Twitter account and my own Twitter account. If you've got any comments or feedback or anything like that about this kind of live coding session, I'd love to hear them. Like reach out on Twitter, let me know, or you can email devrel@nexmo.com and that'll come to our developer relations team as well. But yeah, so Glenn, I think we're slightly over, but if we've got time for a couple of questions.
Sure. Thanks, Aaron. That was great. So I do have a couple of questions here already. For those who are able to spend a little more time with us, please do go ahead and ask your questions here, and we'll answer them. So the first one I can actually field, it's someone asking whether this session will be recorded and available to view, and the answer is yes. When we have the on-demand version available, we will share that with all the attendees, all the registrants, via follow-up email. So you will be getting an email with a link to the recording of the session. And then the second question here asks, how can we implement prosody for text-to-speech? And prosody is qualified with speaking rate / speed. Is that something you're familiar with, Aaron?
It's not something that I think we offer at the moment. We do have quite a few different synthesized voices for different languages as well. So I think actually we can probably just take those links off for the time being and just show us here. So on the kind of the Nexmo developer site, we have kind of our API reference and things, and within actually the voice API call control objects. So there's the talk action that we were using earlier, and listed within here we have this voice name, and it lists the voice names beneath it. So you can see we have quite a few different voices in different genders, and also for different languages as well. So we have English US, we have kind of Dutch, we've got English GB, etc. I think we have Portuguese in there as well, Italian. So that should help in the fact that we can actually have localized voices. Some of the voices as well do have a kind of a different counter than the rest. There's nothing that I'm aware of at the moment that will allow you to actually adjust the speaking rate, unfortunately. The only thing you could do, it depends upon your use case, but we do have as well as a text-to-speech the ability to stream to a call, to send audio. So that might be an option if it's something that you can pre-record. The other option as well is we can connect calls not only to other telephones or to our text-to-speech, but also to web sockets. And that's a bidirectional channel. So if you have your own text-to-speech provider that allows you, that you're already using or allows that level of control, as long as that can output audio, you can actually stream that back into the call over a WebSocket.
Got it. Thanks, Aaron. I hope that answered the question. I actually don't see any other questions queued up here. So again, I will thank everyone for attending. We will be sending up an email, as I said, that will have a link to the recording as well as some of the resources that Aaron shared at the end of the presentation. And with that, I will say thank you and enjoy the rest of your day. And thank you, Aaron.
No problem. Thanks again, everybody, for attending. And as I said, if you do have any feedback, I'd really love to hear it. Just ping me at RMbassett on Twitter. Thanks again. Bye.